Welcome back to Cyber Aces. I'm your host, Tim Medine. We are currently in Module 1 operating systems and we're focusing on Windows. This is Session 4, the Windows file system. The tutorials that you see here are part of the larger set of tutorials available at cyberaces.org. This is Module 1, but there are two additional modules, one on networking and another on system administration and scripting. This is the fourth session in this first module related to Windows, the Windows file system. Let's talk through the basics of the Windows file system. The drive hosting the operating system is typically the C drive or C colon. Now the top or the root of the C drive is C colon backslash. If you remember from Linux, Linux uses the forward slash, but on Windows we use the backslash. So to get to the top or the root of the drive, we use a backslash with nothing after it. We've got the A and the B drive where we use for floppy disks, although I haven't seen a floppy disk in many, many years. Now what I have seen is other removable media. We'll see those typically on the D, E, and so on. We can also map network drives. So remote systems that share folders, we can actually mount those and map those to our systems. And any of these locations can be used with any of the other remaining letters of the alphabet. Our applications are in C program files. If you have a 64-bit system with 32-bit applications, the directory that containing the applications will be C program files x86. The x86, of course, is wrapped in parentheses. That is exclusive to 32-bit programs on a 64-bit operating system. Your users are in C colon backslash users. Now, if you've got an old system like XP or older, instead of users, it's documents and settings. Quite rare to see any of those systems these days. Application configuration information is in C program data. Other interesting locations in our users home directory, so remember C users, then the username. We've got contacts, the desktop, documents. This is going to be the default location where you're going to save things from like Word or Excel. Your browsers are going to default to downloading files to the downloads directory in your user directory. We've got favorites, links, music, etc. The most interesting one here at the end is app data. So this is a hidden folder in your home directory. So C users Tim app data. This is where a lot of applications are going to store their data for the application. An interesting feature of the Windows file system is the alternate data stream. Now this is something you hear about more on the Windows side, but ironically, it was actually taken from Apple. Apple had used this first. Apple used it initially to store metadata about a file. So metadata is data about the data. Initially, it was not used by Windows itself, but with later versions of Windows, what we do with Internet Explorer, the built-in browser, when you would download a file, it would add additional metadata to that file saying this is where the file was downloaded. Specifically, this was downloaded from the internet. So if you've ever seen the warning that from Windows saying, hey, this file was downloaded from the internet, do you want to execute it? That's because of this additional metadata. Now, the vast majority of programs will ignore metadata otherwise. In fact, one of the interesting things is this metadata, when you add it or remove it from a file, it doesn't actually change the file size. In fact, we'll see that here in just a little bit. So let's walk through. Let's take a look at this alternate data stream and what this looks like. So for an exercise, this is something for you to do. I'll walk through it, but I highly encourage you to do this task on your own. But if you go to the Cyber Aces website and then you download the logo and save it as logo.png. Now, of course, you could pick any file. We're just giving you an example. Then we want to open up the command prompt and navigate to that location. If we saved the logo on the desktop, let's navigate to the desktop. Next, we're going to create a file, a simple text file. So we're going to say echo, I need to hide this, and then we're going to redirect that into hideme.txt. So if we use type on the hideme.txt, we should see the contents, I need to hide this. Then we'll do a directory listing. So look at the file size both for my hideme.txt as well as our logo.png or other file you've chosen. Now let's create this alternate data stream. What we're going to do now is we're going to type the hideme.txt. So we're going to get the output, get the contents of that file, and now we're going to redirect it. But what's interesting is look at this redirection. We're using the greater than to output to a file. We're using logo.png, our initial image here, colon my ads.txt. The colon followed by the additional text, that is the alternate data stream. So we're writing the contents of hideme.txt into an alternate data stream on logo.png. Now the interesting thing is if you do a directory listing again, the file sizes look the same. If you compare now versus before, logo.png is still the same size. So let's delete our original hideme. Let's look at our logo. It should load just fine. Now what we can do is we can use Notepad to load this alternate data stream. We can then use dir with this /r option to identify these alternate data streams. Okay, it's time for a review. So this is an exercise we'd like you to perform. So what we want you to do is take a look at these series of commands. In fact, run these series of commands, and then we're going to answer the following questions. So pause it here, run through these commands, or then take a look at the next page. So first question related to the commands on the previous page. When we created this stream, dir.txt, containing the entire Windows directory structure, how did it affect the size of main.txt? Is it going to be the same, larger, smaller, no change? We'll see. Question 2. Viewing the content of an alternate data stream from the command line can be tricky. Try each of the methods below. Which of the following commands will display the contents of the alternate data stream at the command line? So after you've run the commands on the previous page, run each of these and identify the command that will show us the alternate data stream. Okay, now you've done this challenge, I trust, right? So the first one was when we created the stream dir.txt containing the entire Windows directory structure, how did it affect the file size of main.txt? It did not change this file size reported by the operating system. That's an interesting thing with the alternate data stream. It is not reported. Question 2, we said it was tricky to view the alternate data stream. Which of the commands will allow us to view the alternate data stream? The answer here is more, less than and then the path to the file, colon, the name of the stream. So what we're doing here is we've got the more command, which will allow us to page forward, and we're going to send as input the data stream here. So the file, colon, stream. Let's switch over now to permissions. Let's talk about mandatory integrity controls, or MIC. What this does is it prevents one trust level from modifying those of another. What we commonly do is we commonly associate these different integrity levels with process permissions. We've got a couple of basic different use cases here. For example, with low, this is going to be what our browser does. It has a low integrity. So if that browser is compromised, the impact on the user or the file system and the operating system at large should be dramatically lessened. It should prevent any sort of wide-scale issue. Level 2 here, our medium, this is what you as an average user are going to have access as. The high integrity, this is, you probably have done this before. If you try to modify a file or make a change to Windows and you get that little pop-up and it says, hey, are you sure you want to do this? This is what's called UAC, UAC is asking you, hey, do you want to actually switch to this high integrity? Is this an action that you are actually intending to take? System, this is the operating system itself. This gives it full access to absolutely everything on the file system and every access to the operating system. Now, these lower integrities are not authorized to modify the higher integrity. Now, every once in a while, we do have a case where a lower integrity is allowed to modify a higher integrity, but that's definitely not the intended way. That is going to be a security vulnerability because these different integrity levels should not be able to modify each other. We also have DACLs, or our discretionary access control lists. Our DACL is similar to the permissions we talked about on the Linux file system. Now, on the Windows side, we have a lot more permissions. Remember, from Linux, there was simply read, write, and execute. On Windows, we've got a large number of permissions. We've got, of course, read, write, and execute, but we've also got full control, which allows, gives us even more control over the file. We can modify. There is a permission to read the permissions and a permission to modify the permissions, not just modify the file, but modify the permissions themselves. And there's a large number of these different permissions that we can toggle. On top of this, we can also do some inheritance, and we'll talk about inheritance in just a second. Now, these DACLs are independent of each other. So I can give user 1 read access, and then user 2 write only access. And then user 3 has read and write access. If you remember from Linux, we could only apply the permissions to the owner of the file, the group, and then everyone else. So we've got a lot of granularity here, but then also with a lot of rope, we may potentially hang ourselves. So with our inheritance of permissions, what this allows me to do is set a permission higher on the file system, and that permission is going to cascade down. As we get further down the file system, or maybe on one specific file, I could adjust that to maybe contradict or add to that inherited permission. So my two basic options are to allow or deny. So I might allow a specific user to read at the root of the file system. But then maybe further down we'll say, look, there's a directory here where we are going to deny your access. Or maybe we are allowed to read, but we are denied access to write. Now, as we traverse down this permission precedence, there is a hierarchy. The most specific, the one that will always win, is going to be an explicit deny. So if I, on that file, say, look, this specific user is not allowed to read this file, it doesn't matter if higher up in the directory structure, they were given access to modify that file. So the least strength is the inherited allow. And you'll notice here that denies will trump the allows. So if we are inheriting an allow, and then further down there's another inherited allow, those are going to be sort of added together. But if there's a deny further down, the further down in deny will win out with the allow. So for example, let's say at the root of my directory structure, I allow myself to read. I have permissions to read. But if we go another directory or too deep, maybe there's a deny that says, hey, Tim, you're not allowed to read any further. If I then go further into that directory structure and attempt to access a file, we have an inherited allow and an inherited deny. That inherited deny is going to win over the inherited allow. Now, if we've got just the allow at the higher level, we could explicitly on that file or directory say, look, Tim has permission or doesn't have permission. The explicits do win. So even at the very top, you say, look, Tim, you have access to nothing here. But if we explicitly on that file say, you know what, you actually do, then that explicit allow is going to win. Let's run through a couple of questions here. First, if a user is a member of two groups, one of which has the explicit allow read and execute of a file, and the other has explicit deny read and execute, will the user be able to read the file? Yes or no? Question 2. If a user is a member of two groups, one of which has inherited allow read and execute of a file, and the other has deny read and execute, will the user be able to read the file? Question 3. If a user is a member of two groups, one of which has explicit allow read and execute of a file, and the other has inherited deny read and execute, will the user be able to read the file? So think about these for a minute. Pause here if you need to, and then go on to the next page when you're ready. All right, let's take a look at these questions. Question 1, user is a member of two groups. The first gives me an explicit allow. The second group is an explicit deny. Can I read the file? Of course, the answer here is no, because if we have two explicit, the explicit deny is going to win. Question 2, same user, two groups. We have an inherited allow and explicit deny. In this case, the user will not read the file. Remember, the explicit deny wins over everything else. Question 3, we have an explicit allow and an inherited deny. Will the user be able to read the file? In this case, yes. Remember, the denies are going to win out over the same type of an allow. But here we have an explicit allow, whereas we have an inherited deny. In that case, the explicit allow is going to win over the inherited deny. Congratulations, you have just completed the file system session here, this module. So module 1, operating systems Windows, you have completed the file system session. Next up, users and groups.